Solving rational equations. To solve rational equations, all the denominators need to be factored so we can find the least common factor. So let's start that process. Extend these fraction lines just a bit. And then I'm going to rewrite the numerators so that they're all on the left with parentheses. So parentheses x minus 1, parentheses x plus 2, and parentheses 2x plus 5. All right, now let's start factoring the denominators into, let's see, binomials. Okay, the x squared minus 2x minus 3 factors into x times x, and the 3 factors into a 1 times 3. And since we have a negative 2, we're going to make the 1 positive and the 3 negative. The x squared minus 9 is a difference of two squares, so we'll get a conjugate out of that. So square root of x squared is x, and the square root of 9 is 3. So we'll have 3 here, and we have plus and minus. Okay, x squared can be factored into x times x, and 3 can be factored into a 1 times 3. Since we have a positive 4, we're going to have two positives here. I know it's kind of hard to see right there. All right, now let's go for the least common denominator. Okay, starting from here, I need an x plus 1, so x plus 1. I need an x minus 3. This says I need an x plus 3. This says I need an x minus 3. I got it. This says I need an x plus 1. I got it. This says I need an x plus 3. I got it. So this is my LCD with everything that's needed. So let's start putting the extra stuff in. Here, to create an LCD here, I need to add the x plus 3. But whatever you add to the denominator, you add to the numerator. So another x plus 3 here. Here, I don't have the x plus 1, so let's include it in the denominator and in the numerator. And here I don't have the x minus 3, so let's put it here in the denominator and the numerator. All these minuses can be seen here. All right, now that all the denominators are the same, we can actually remove them and just use only numerators. So the numerator is x minus 1 times x plus 3 plus x plus 2 times x plus 1 equals 2x plus 5 times x minus 3. Now we're going to FOIL these, multiply the first, the outside, the inside, and the last. We'll get x squared. And just to make sure we have separation between this process and this next process, I'm going to add a parentheses. The parentheses aren't not necessary. I'm just adding them for clarity. So that's first. Outside will be plus 3x. Inside will be minus 1x. And last will be minus 3. Then the next one, first will be x squared. Outside will be 1 plus 1x. Inside will be plus 2x, and last will be plus 2. Here, first we'll have 2x squared. Outside we'll have negative 6x. Inside plus 5x. And lastly, minus 15x. Again, these parentheses are not necessary, but I just wanted to hopefully it gave a little clarity to which ones we're working on. All right, combining like terms here. The x squares combine to a 2x squared. The x's, we have a 3x, negative 1x, a 1x, and a 2x. That'll all combine to a 5x. And the negative 3 and the positive 2 combine for a negative 1. On this side, we have a 2x squared. The negative 6x and the 5x combine for a negative 1x. And then there's negative 15. Now, I'm going to subtract 2x from both sides, 2x squared, should I say. And that'll leave us with 5x minus 1 and a negative 1x minus 15. From here, I'm going to add 1x to both sides. And then I'm going to remove the 1 here from this side, so plus 1, plus 1. This will give me 6x equals negative 14. And then from here, we'll take out 6x equals negative 14 and divide both sides by 6. This will give me x equals negative 14 over 6. And I can simplify this by dividing both by 2. And we'll end up with x equals negative 7 over 3.